That's my hey,
Okay, I think we're ready to start. So, Quaylen McNamara is going to be talking to us about porting LibreOffice to use GTK3 and all the great things that gives us. So, over to you, Quaylen.
Okay, can you hear me? Yeah. Okay, so I'm alright, and I will do a quick, in theory at least, demo of the works. Alright, so this is the GTK3 enabled version of LibreOffice. So you can see that obviously renders straight away. We have our highlighted menus, same as a standard GTK application, and the theming is working there on the menus. We'll do a little dialogue, which has appeared on my screen here. So we've got a blue border around the edit, same for the spin buttons. Spin buttons are in the standard GTK3 theme. Checkboxes, etc. Focus. No.
Right.
And we have little focus rectangles, which you probably can't see in that, but we have native focus rectangles as well. So yeah, basically it works. And I will give a little demo then of what's new that doesn't exist in the GTK2. I'll be much of a demo anyway. Usable actually. Okay, well the purpose of that demo, which hasn't worked out too well in practice, which I'll get up running again, is that I have touch support implemented for GTK3. So when you have a slideshow up and running, when you do it right, you can scroll backwards, forwards, through the slides with touch, which works a lot better, but the demo is a bit more organized than that. Anyway, back to the presentation. And the demo, it works. And I'll do a quick preview of the architecture of how we got this far. The underlying work here, most of it is mine, but under VCM, each platform is its own style instance, and each style instance then consists of various create and destroy pairs for frames, printers, virtual devices, and a whole pile of other stuff like that. And each platform has to implement all of these. On most platforms, like Windows and Mac, you just have a single one and it's built in. On other platforms like Linux, then they're in dynamic libraries, and they're loaded then depending on which one is detected. Typically, of course, cell frames are system windows, so they map to the XLM windows and direct. And virtual devices then tend to be pixmaps. Now, cell graphics then, which map to your top-level windows, and your virtual devices then map to pixmaps, and each one of them has then acquire graphics, which gives you back a style graphics. And you use your style graphics then to actually draw on the output device. So, that gives you your APIs like drawing a line, drawing a rectangle and things like that. A lot of our APIs are optional, so we have fallbacks for those cases where they're not implemented on a given platform. So you can have some very, very fat ones, such as drawing an EPS, which is only implemented for the printer backend, and not implemented for anything else that falls back to getting a fallback graphic out of the EPS and displaying that on the screen. And then as part of that, then you have the native widget framework, which gives us the theming for the platform that you're on. So we're not actually using the native widgets, we're just using those native widgets' ability to draw themselves onto the top level frame. So we're not using GTK buttons or GTK frames, we just have a single GTK window at the very top, and then use the drawing system then to emulate them all on top of our own implementations. So usually there are some sample implementations we have, with the Windows one, we have the Mac one, the Quartz one, and then we have the one we have under Linux. And they're all dynamically loaded depending on the section type. So we always had, or at least as far back as I know, we always had the generic X11 one. And we did at that point then was we just inherited the KDE2 one and the GTK3 one and KDE one from it. Now the issue there, of course, is that whenever we didn't need to implement something, and the old X11 one was able to do it anyway, we just left the X11 implementation there and reused it. That's what we have here. So we inherit from the X11 style frame for GTK1 and so on. A lot of places then, as I said, we just take the underlying XID of the X version and we just do all the tweaks to it manually. Printing, we just use the generic cups backend, which we reuse mostly on Linux and on Mac. And the entirety of the cut and paste and the drag and drop stuff we have is all the X11 one. So even on the GTK2 port, a lot of what we're doing is all X11 based. So when it comes to the GTK3 one, we have a problem is that we can't just redo the bits that we did in GTK2 and redo them and we have a fully functioning GTK3 version. Because we have all those old X things which were never done with the GTK APIs in the first place. With the change then to trying to do Wayland and all that, we have to move away from using pixmaps directly and all of the rest of those DirectX stuff. So we do so in that case then, for the pixmap surfaces, we need a replacement for that. And the same. What we have at the same time is we have a headless plugin, or an SVP plugin, where SVP was Starview Portal. That was meant to be used for server applications and headless cases, where we do document conversions and all that. Started off as a proprietary add-on for StarOffice, and ended up getting rolled back into the OpenOffice about a couple of years after it. So it was created as an optional part of OpenOffice because of its historical disconnect from the original codebase. So again, the headless mode is implemented in the same manner as any of the other backends that we have supported, the X11 one, or the Quartz one, or the Windows one. And it comes with a mostly complete style graphics mechanism for drawing into it. So it is not as fully featured as the Mac one or the X one, in the sense that it's missing a whole pile of stuff like alpha blends and various things like that, and falls back then to slightly substandard fallbacks. So the new GTK3 one then effectively inherits from the SVP headless backend, and then we bring in a whole pile of stuff from the GTK2 backend which did not rely on X. So you've got a kind of a merge there of GTK2 one and the SVP one to give you the GTK3 plugin there. Now, getting it that far, not much of that is anything really to do with me. The headless backend was already there from Sun, and Mike and Meeks and co got that bootstrapped and up and running. But that was between about 2011 and about 2013, and it wasn't complete and wasn't going anywhere very fast. Michael was using it as the demo for the Broadway demo for the online LibreOffice. So it was more kind of a demoware at that stage than actually something that you could use. Alright, so that's where we were around, I suppose, January or February this year. And it became a kind of priority for us to get GTK3 support working so that we could get Broadway support along with that for LibreOffice, and so that we could get some basic touch support up on top of that as well. Given that GTK3 comes with fairly straightforward APIs for touch, but I wanted to go and put all those things together so that we wouldn't duplicate the effort coming down the line. Alright, so the headless backend sits up on top of our base BMP bitmap buffer, which has completely different stride as Kairos. So there's a whole pile of format conversion code everywhere just to try and match it up. It seems like a whole lot easier just to change our structures to match those with Kairos in the first place so they have the same stride. Same thing as well then finding a format for base BMP which would match one of the formats that Cairo uses is an awful lot easier than doing a whole pile of conversions and making mistakes everywhere. So creating the RGBX format for our backend allows us then to use Cairo to draw directly to our surfaces, and then we can copy directly from our surface to the Cairo context provided in the draw handler. Right, so the first problem there is that that's a 32-bit bitmap format. So it takes 32 bits of space even though we're only using 24 bits of it. And that gives us a whole slew of errors all the way down our graphics stack where we're just not supporting 32-bit things correctly at all. A lot of work there in fixing all those pre-existing bugs. We also have to improve our Cairo text rendering to be reusable for this surface as opposed to drawing directly to the X bitmap as we were in the past. And drawing true. So that base BMP then existed just as a surface we could draw to for a long time. At this point then we wanted to actually know what bits of it had been modified at any particular time, so Michael added damage support to all of that. The idea then is that, and all those damage had you right to the surface and you damage an area that we just directly route that to QDraw area. And then because of the simplified bitmap buffer I described earlier, we can then just copy that section from our buffer straight to the context that was provided from draw. Problem there then is that we have a whole stack of just graphical artifacts all over the screen. The damage tracking is fairly new and just wasn't correct. So again, vast quantities of debugging all the way down there again. In the damage tracking, pile of corner cases, lots of existing problems in our X backend where we have various bugs, but we rely on those bugs to be that way. So then you go back to your bitmap surface damage tracker and basically break it to be the same as everything else that's broken, so you have consistency there, and that things begin to work correctly. The native widget drawing, some parts of it were implemented in our GTK1, so some things kind of worked, but not sufficiently that you could actually, use it and be confident about it. So again, go through the entirety of what we did in GTK2 and come up with something that's equivalent in the GTK3 one, so at least we're visually similar in both cases. Luckily enough, because coincidentally GTK3 has a lot of things in it that are very similar to what we have in the Mac. A lot of the Quartz hacks that we have in that backend can be used in the GTK backend as well. So the focus rectangle slightly outside the widget, things like that, they're all corner cases that we really had support for. It's just a matter of using them for GTK3 as well as the Mac one. What I found really particularly difficult for the native widget is the finding of the right context and styles to match what you see in GTK3 to match the correct combination of those in GTK3. To find that is difficult enough. So you often end up going back into the GTK source itself to find out what exactly the combinations are. So common one is trying to get little menu arrows in your menus drawn the same way that GTK does. You have to go find out, is it using the menu context, the menu item context, what state is it in, and so on. So again, it all just sucks time. But that does allow us in GTK3 to get some gesture support. So we have the swipe, long press, and a couple of those that are in the slideshow at the moment. There's also some other work going on in the Android port, so we basically need to merge what we're doing in GTK3 with some of the work in Android so that we get the same, we can make use of the support that's being added for mobile devices and make use of them for the FAT app as well. We have auto mnemonics in menus and menu bars as well. That's not in 5.0, that will be in 5.1, well, that's a backward, that you hold on your Alt key and the underlines appear. That came in very recently from Raspberry Pi, so I'm pretty sure with that. Yeah, so it makes it much more like a GTK3 application. So that's the laborious stuff, but not particularly different from what we already had in GTK2. But as I was saying earlier, because we used to just inherit from the X1 and we ignored the whole pile of stuff, now we have to go and redo them again with the actual GTK3 APIs, as opposed to just relying on the historic implementations. So, two ones there are cut and paste. Yeah, so you have to do that from scratch. So I was putting that out for ages, but the APIs aren't as bad in GTK as the original X1s are, so it's all fairly cleaned up there. So about a day or two effort there for cut and paste. Accessibility was difficult to figure out, not because it's difficult to do in GTK3, it's actually pretty easy in GTK3, but because we had to do it in such a complicated way, it took quite a while to realise that the whole entire complicated stack that we had done in GTK2 could be replaced by about 4 or 5 lines for GTK3. So again, accessibility much easier to hook into in GTK3 than it was for GTK2. Cut and paste, again, much easier to do than expected, far smaller than the actual X implementation. Yeah, so for GTK3 there's a get accessible member that we can make use of, and we can just take this entire huge block of code and just, replace one line to set that there. Right, so that's getting us up and running, and in the demo there is just GTK3 under X, and that works equivalently to GTK2. I think it looks better than the GTK2 one, naturally more natural, native than the GTK2 one does. So once that was done, then we're looking at what to do with Wayland and see will it just work out of the box on the Wayland. So start it up under Fedora 22, and you see nothing at all, blank, big blank. So yeah, so the set double buffer, I know it's documented as saying don't use it under anything except X, otherwise it won't work. It'd be good if it said that at runtime. You've just used double buffer, it's Wayland, it doesn't work. Otherwise you just see a blank screen and you're wondering what it is. When you go back and you reread the documentation that you had read a couple of years earlier, when that line wasn't in it, then you go back and you read, oh, there's a new line that says don't use that. Oh, don't use that. Then you get some content. Yeah. You get some content, but it's all, for us, offset up to the corner a small amount. So what we were doing there is we just have a top level GTK window, and they were claiming that we're going to draw to it, we're going to handle all the things about it, and don't you worry about GTK. So that's fine, GTK doesn't. And under Wayland then, the entire decorations and whatnot are inside the window, so that you are trying to draw underneath where the decorations appear. So it's all offset to one side. So easiest solution here is that you just put a single child into it, and then you claim you look after the child and not the top level. So you do that, you get the draw event, and everything then fits into the right place. So what we have in our case is we have a top level GTK window, then we had one single child which we're using to capture the accessibility events in the previous slide. So now that top level child, which is just a fixed, inherited fixed, is now the one we draw to instead, and leave the top level one alone for drawing. The next step then is the windows unresizable, and similar problem again. We're connecting to mouse events on the top level window, and they don't actually, it doesn't work. Doesn't work. Again, straightforward again. Put an event box into the stack as well. Start listening to mouse events and gesture events on that window as well. So basically just top level window, completely toxic, don't touch it. So similar problems still remain for sizing of the window, we need to work with the child and not the top level. Right, so that's where we are at the moment. We have it working fine for X, mostly some improvements there. We have it in Git, we have it working for Wayland, but only some minor noticeable issues there. So what's left over to do? We don't have video playback yet. I don't think it should be particularly difficult to do. I've just been putting it off because while I think it's straightforward, it's still a fairly corner case in presentations to stick videos into them, so I think it's worth my while spending more effort on the more common things first. The sizing tweaks I mentioned there with the top level, we have a whole lot of code that tries to figure out what the real size of the window is, taking into account decorations and things like that. It's all redundant now, so we'll have to basically remove a lot of that for GTK3 and clean things up. So under Wayland, your size is still not quite right. It works perfectly fine, but it's the wrong size. The selection rectangles, a lot of cases we're still using the XOR selections or we're using stippling. That's not implemented in the base BMP headless backend. And that's part of the general problem then, is that the SVP one is designed for that document conversion kind of a case, not for the visual screen case. So a lot of things aren't implemented fully there. So what we have problems with is SVGs look a bit jagged, alpha blending isn't complete in a lot of places, and issues like that. So what we need to do is we need to improve the headless backend in order to improve the GTK3 backend. Because the Android backend is also implemented on top of ASBMP, you get two platforms improved for working on one area. Another issue as well then, and you'll see it in the debug output, is that all of the bitmaps, the 32-bit case, is an unoptimized case. All the work has been done on 24-bit and 16-bit and 8-bit, so there is a lot of work available there to improve those cases. So those will be the next things to do. Once they're done, we'll have something that's pretty good. But coming down the line, after that, this whole theming stuff is just very, very awkward. So it would be a lot easier if we were an actual, real GTK application in the first place. So how could we go in that direction? Well, we already have the case under Mac and Unity that we use the system menus, and we just fill them from what the contents of our ordinary menus would be. We could probably extend that and actually just put GTK menu into our application in the first place, at the very top. Don't bother with our emulating of anything, and then just fill it the same way we do with those other platforms. So you'd have native GTK top level, native GTK menu bar, and then one widget which would be everything else belonging to us. The other thing we did last year and the year before was that we ditched our old file format for dialogues and all the rest of the UI components, and we moved everything over to the GTK3 builder file format. Just file format. It's still our loader, our code, our widgets, themed with the GTK engine, but it's still our code and our that. So I've feature branched a little demo where the actual .ui files that we normally load via our code and then pretend to be a GTK window, we actually load it with GTK and show a true native GTK message dialogues, just message dialogues for now. And that works reasonably well. So I could see that we can move a little bit further in that direction and actually just start loading everything directly with real GTK dialogues, turn our existing widgets into just wrappers around the true GTK ones. And that would get us pretty far. It would work fairly well for lots of basic dialogues anyway, and I can see how we can manage more complicated ones as well. But the hope I had at the last conference about kind of going in that direction, I think one of the steps would be localization and all that. So it would be handier if we also moved away from our existing infrastructure there to a simple get text one. We have some complicated process, but fundamentally we have our own file format for translations as well. If we moved everything over to get text, solve a lot of problems, but then it brings in the issue, for us at least, size. It doesn't seem to be an issue for other projects, but the full contents of your source strings are in the MO files as well, each individual one. So it will explode. So I don't know if there's a solution there, but we need to look into a way of doing that. But if we were able to do that, we could move to get text, then we'll be able to localize via GTK the GTK dialogues that would then be native in the GTK file format, and then would be pretty much it. I mean, very blue sky at that point. Could you just move all of our platforms over to GTK for Mac and Windows as well, as opposed to keeping our three major ports alive? Okay, thank you for your time.
How many questions?
Would you mind doing a rundown of which bits of GTK you are using and which bits are being re-implemented at the moment?
Your top level window is a GTK window, each individual one. Then inside of that, we are using all the GTK cut and paste APIs, all of the, I'm not sure, we call them the native widget framework, the actual widget drawing calls. I don't know, what are they called? Anyway, the widget drawing calls we are used as well. What else?
So you don't actually have a window containing GTK widgets, like LibreOffice tracks what the widgets are and asks GTK to draw them?
Yeah, basically, because you have a top level real GTK window, you have a real GTK event box, and then you have a real GTK fixed container, and then we draw everything inside of that, but we ask GTK to draw it for us in pieces, and we have our own actual widget hierarchy inside of it, which only belongs to us and not to GTK.
Okay, that makes sense. Thanks.
Any other questions? In that case, thank you very much.